Put your hands together for Cynthia.
Hi guys, how's everybody? You guys know everything about container security now that Thomas has spoken, right? Well, he did leave some room for me to talk about networking, which is good, because I come from a networking company. So one thing, I don't know if you guys noticed, the first talk today, Alex Williams showed a survey about interests of container orchestration, what was at the top of the mind. And it was config management and all that good stuff high up there. And then, of course, networking was 1% on 1% of people's minds, which made me sad as a network engineer. But that's OK, because, well, I'm here to tell you it is important. And let's not let it lag like other technology shifts, like in virtualization. Networking was the last to follow. So here we are today. Security is pretty, security is good, but it should never be pretty good. So what does that mean? Well, it's not always pretty and it's not always good, so I guess I started with a lie. I mostly did that so I could say, this is a call to all, for those Foo Fighter fans, who want to secure their containers, basically. So we're at a time where lots of shift to containers through microservices and all that good stuff. So let's not fall behind with the networking and security aspects of it. Now's a time where we can leverage existing technologies. We don't have to reinvent the wheel. We can just quickly adapt and move to a model that exists basically with what we're going to talk about is container network model and things you probably already heard about a little bit earlier today. One of my friends said I should put GIFs in this Prezzo. I don't know. Instead, I looked for a picture that kind of looked like him. So what we're going to talk about today is why do containers what do they do to the network? What are the container networking options? We saw some of them earlier today. So we'll talk about those. What can Courier deliver security? We'll talk about what is Courier too, and can it deliver security? I actually didn't even introduce myself yet. So my name's Cynthia Thomas. I'm a systems engineer at Midokura. And one of the products that we help support, which is now an open source project also, is MeDoNet. So MeDoNet is an overlay technology for networking. So we'll talk about that as a scalable solution and how it can enable container security as well. So you can protect against these scary characters, protect your containers. So what do containers do to the network? So obviously the enablement of microservices through containers has, in the end, added complexity to the network. So we have a lot of crazy traffic flows. We have containers all over the place in the data center. We are traffic tromboning potentially, so we have more endpoints, network scaling issues. So when we moved to virtualization, we started basically increasing the number of workloads on a single host. Now with containers, we're drastically increasing the number of workloads through containers since they're so lightweight. The density you get on a host is much higher. And then in turn, you have the actual potential to exhaust MAC address tables on physical top of racks. So you got to pay attention to the underlying infrastructure as well, where these services are lying and communicating with each other. Then, of course, what we're talking about today is security and policy complexity. So with all these things going on, do we want to use appliances to get those security functionality type working to segregate or deny services? Do we want to enable policies? How do we want to do that? We want to remove bottlenecks in the network, though, for sure. So basically, initially, it seems a little bit ugly. So one way to get over the hump with some of those limitations that come with microservice complexity is keeping it clean with overlays. So network overlays like GRE encapsulation, VXLAN encapsulation, these types of overlays can be used to minimize, protect against those MAC exhaustion issues. We'll see, with this MidoNet implementation, for example, we can achieve a lot of these higher layer network services just through a software agent residing at the edge, so we don't have to have traffic trombones to service appliances, for example. So we can have overlapping IPs, tenant isolation, Also integration into several growing areas like container orchestration engines, many of which were mentioned here earlier. So solving those networking issues with overlays and then talking about security, let's talk about Neutron. So how many people are familiar with OpenStack and the Neutron project? A handful? Okay. So Neutron is basically a project under the OpenStack umbrella. These are all open source technologies. Neutron is focused specifically on solving the networking within cloud. So this has been around, well, initially it was Nova Network, which is the compute project under OpenStack. It was pretty bare minimal for types of, in terms of network functionality. But then it ended up being a dedicated service, and people who are involved in OpenStack know that now there's a host of projects available. But Neutron was a really important project because it isolated and focused on networking. So let's look at how Neutron, well, the hint is overlays can contain the container security problem. So we'll talk a little bit about libnetwork. So for those who might be familiar, just to review the networking options within Docker. For libnetwork, we talked about a little bit earlier. Null, so no networking, I think pretty much self-explanatory, and therefore backward compatibility purposes. Bridge, the default, Docker 0 hanging out there. Overlay, which we talked about, ways to achieve cross-host communication through VXLAN, for example, and then the remote driver. So how about networking with security? Yeah, I don't know. I don't really know an answer for null. You have to figure it out on your own. Bridge and overlay. Now, part of the implementation is IP tables, so I'm guessing you can probably hack something together with IP tables, but it's not inherent in the definition today. So that's where the remote driver comes in. The remote driver enables the ability to plug in any kind of remote driver, basically, and have the capabilities on the back end to provide whatever networking and security functionality that you would like. So in this example I'll talk about today is enabling the Neutron framework, which has higher layer services, including security, policy, firewalls, also load balancing, NATing, all that good stuff. So that's what we'll talk about today. So the remote driver allows plugins to be inserted. You can have these plugins written in language of choice. It enables multiple vendors or open source projects to be inserted. Enables those higher layer networking services. So the point is, Neutron from the compute and virtualization world in OpenStack can now enable containers to have those higher layer services. So while CNM and CNI continue to be defined, as well as policy, we don't have to totally reinvent the wheel. A lot of this framework was done with Neutron, and that's been tried, tested, true, battle tested and political battles and technical battles have been done already. So one example is Courier as an enabler for the Neutron plugin. So the drawbacks are the three earlier drivers were native to Docker, whereas the remote driver is not. So how do I keep my containers airtight? Well, as you guessed, let's try to use Courier to enable the Neutron security groups, for example, into Docker containers. So for those who aren't familiar, Courier is actually a very new open source project. Well, I wouldn't say totally new. It's actually almost a year old now. One of our developers is actually involved in founding the project. He likes Czech things, so for those who might not know, Courier is Czech for courier, so deliverer of packets. So the purpose of Courier is to implement the libnetwork remote driver and basically do translations from libnetwork to the OpenStack Neutron API. It also acts as the IPAM driver as well. So Courier is an OpenStack project, but it's completely open source. Just happens to be under OpenStack umbrella. It doesn't actually require a full OpenStack deployment in order to enable this type of functionality for a container world. So I mentioned one of the founders and actually another one of our developers were heavily involved in the heavy uplifting initially for a lot of the code base. So as you can see, Midokura is one of the top contributors, but since then, since its inception, many companies have gone on board who agree with the idea that this is important and can provide higher layer services. So lots of great community work going on there. You probably saw this earlier from Brandon's slide. He forgot to mention MeDonuts as a plugin. I'm going to have a chat with him later about that. So the container network model, this is right off the libnetwork project as well. So basically, it's a construct quite simple, the three main constructs, the endpoint, the network, and the sandbox. So easy definitions, but how to leverage them. So Courier does that mapping, basically, from those libnetwork constructs to things that Neutron understands. So network is network. The sandbox can be subnets, ports, network namespaces, and endpoints, as you can guess, would be ports. And for example, MidoNet as a Neutron plugin can implement these ports into the software. In a logical topology, a port is just at the end of your network, so it can represent a VM, can represent container, so you can do that mapping. Just to give you an idea what's going on with libnetwork call when you're going and you're attaching a container to specific network, it's going to make an IPAM request for an address, so that's where Courier is providing its IP address. Retrieving that from Neutron. Then furthermore, creating that endpoint, so all the things you can imagine with an endpoint, the MAC address, and things like that. Then finally, the network driver does a join. So as you can see here, the plugin was used, or is using this example, is MidoNet. So basically, for the remote driver, the things that are specific to the backend implementing the plugin is this VIF binding. It's this. So in the MidoNet case, it's a VETH pair basically between the container's network namespace and the MidoNet data plane. So that's more of a implementation specific. So where external vendors or projects would have to contribute that VETH binding. So that being said, I talked about MidoNet a little bit, just to give you a little bit more about MidoNet. So yeah, I'm a systems engineer at Midokura. MidoNet has been in the works for 6+ years now, so I'm a hardened, resilient platform. Its founders are actually initially it was founded in Japan. That's where the two co-founders are. They're at the top, our CEO and our other co-founder, TK and Dan, are there. And our CTO, Pino. So Pino and Dan are actually Cornell grads who worked under Werner Vogel. And they spent some time also at Amazon. So their expertise is basically distributed systems. So their goal is to build a product, software that could scale, was a distributed system, highly available, no bottlenecks in the network, no single points of failure. So when building a software networking platform, those were their goals. So we've been involved in the OpenStack community since the B release. We were involved in a lot of the standardization of the Neutron API, the networking framework. So we're tightly tied to it. We continue to contribute to it in various ways, providing blueprints. The actual API is a REST API for MidoNet. And it does go above and beyond what basically the generic Neutron API provides. So it gives you that flexibility. What else did I want to mention here? Yeah, so basically we've been open source since the fall of 2014. So we highly encourage you to check it out, try it out, and all the code is available on GitHub. Just to tell you the differentiators of MidoNet and why it's important in terms of how it can scale, which is important for these cloud environments where containers are dynamically being created and formed. Well, we need those networks created in a dynamic fashion as well. So as I mentioned, MidoNet is built without single points of failure to be highly available with this distributed basically capability in mind. So just to talk about how these tunnels are formed, for example, so let's say a container or VM has an endpoint in a logical topology, and this logical topology can be created anyway. It could be through a specific developer as a tenant. They can go in and create, a network, router, load balancer, connect, wire things up. And from a developer's perspective, I don't know how much they care about networking, but they always want everything working. So they want everything to be reachable, connected to the internet or wherever. That's what they care about, uptime. But from an infrastructure or cloud architect's perspective, they want something that can scale, is highly available, and isn't going to fall over as soon as you get more than 20 nodes in it. So the way the MidoNet agent works, it provides layer 2 through 4 networking services without having a controller. So every agent, there's an agent sitting basically on each server as a workload, like a container or a VM, initiates traffic. It basically is being controlled by the MidoNet agent and what it can do or how the packet's manipulated. So it's a controllerless based system, distributed intelligence providing this layer 2 through 4 networking services. So what does that mean? That means there's no service appliances providing security, for example, or load balancing. We even handle stateful flows. We have a distributed gateway for ingressing and egressing out of these overlay environments. And this is all achieved, basically it can be done through VXLAN or GRE encapsulation. So that's basically the tricks of the trade here are, we're basically doing a simulation of a packet going through this logical topology, determine what happens with it. If it needs to be NATed, we NAT it. If it's going through this many routers, we say, okay, IP TTL decrement here. And then we manipulate the packet. If it's supposed to go to a load balancer's backend pool member, okay, put it to that as the destination, and then encapsulate in VXLAN and send it on its way to its egress host. And that being said, from a security perspective, it's handled right at the ingress host. So that means, this traffic is not even supposed to talk to whatever, some far end container on the other side of the data center. Then I'm going to drop it right before I'm not even going to send it off my host. I'm just going to drop it because my policy said drop it. So that's pretty cool. Not sending unnecessary traffic. Well, I don't want to take too much time about that. I'm available to talk more about that. Also, check out our website. We have some blogs there. And I'm available. I'll be here all day, so we can talk further more about that. But specifically in terms of networking or security, the way we're achieving security. So those who might be familiar with Neutron, well, maybe I'll just assume not, because not that many people rose their hands for Neutron. So Neutron has this concept of security groups. And security groups can be applied to a single developer, tenant, for example, or they can be applied globally, for example. But basically, it's a whitelist. It's denial, and the whitelist is who's allowed to talk. And it's a port level firewall, for example. So that's the Neutron definition. But when it comes to the actual implementation of MidoNet, MidoNet translates those rules, any policies, load balancing, NATing, for example, and we implement it through these lower level constructs called chains and rules. And these chains and rules they don't have to be visible to the cloud administrator or the tenants. They're automatically created and destroyed upon the process, the life of the workload, for example. But they are important on how we implement load balancing, NAT, these firewalls and security group policies. And they're more feature rich than just what security groups from Neutron can do. So you have much more choice in what you can handle. So that's the security aspect of how we implement Neutron security groups. But above and beyond security, there's this host of functionality that is completely distributed through MidoNet. So all this layer 2 through 4 network functionality is achieved just at the edge, basically, of your network. So the point here was Courier, as I mentioned, an open source project, can deliver more than pretty good security. So we can leverage this existing framework and basically apply it to containers as endpoints. So we don't have to reinvent the wheel, and we get access to this rich feature set that can be applied to containers. All right, so thinking to show you a little bit of how it looks. Let's see. can I close this? Let's see. All right. I think I lost connection. Oh, no, I didn't. Okay. So I have a couple windows open here. Let's see. Sorry, I'm going to be peeking over my shoulder a lot here. Just got logged in. I have a host. Basically, it's running Docker and Courier as a service with MidoNet. So just to give you a look at the networks. So you guys are probably familiar with at least 3 of them here. So those are default networking that's set up by Docker. I have an example of Courier running here. I'm just going to set up a couple of networks using Courier. So I have this front end, webnet. These are kind of just generic examples. And they're spitting out their UUIDs. And then our back end, basically, DBNet. So we can take a closer look at each of them. If I could spell. So yeah, we see that this range was taken in. The gateways are there. That was retrieved through Courier. Next, I'll show you some of the integration into OpenStack. So yeah, as I mentioned, OpenStack is not required. A full OpenStack deployment is not required to use Courier, but we just set up Horizon here anyway. You can have a look. So we will check these networks are created here. So I created. So there's still work to be done. We need to clean up how the names are looking. But basically, it's the UUIDs that are passed through. This was the front end one that I created, and this was the back end one. So that's sitting there. That's sitting there in Horizon through Courier and exists in the MidoNet topologies. Kind of like what Mano said earlier. The demo doesn't show you what MidoNet is looking like and doing. It just everything's on the back end basically, so it's not so obvious. So we'll just create a couple of these. A couple instances, one on each network. So we're seeing that they are getting an address in each subnet. So now we can take a look. And we see that there's containers here. They've retrieved an IP. An IP address. I think I'm running a little bit out of time, am I? So the point is, these guys got their IP address. It all came through MidoNet. I'll take you a little bit through what MidoNet looks like. I talked about those rules and chains, so I want to make sure you guys at least see what that looks like. Actually, so in the MidoNet world, a bridge is a network. So, yep. Again, as I mentioned, part of this is like the fleshing out with Courier and the remote driver how to pass through resources, labels, and retrieving on the back end. So, for now, these names are the UUIDs. So I can just basically pick one. Let's see. Actually, I wanted to look at DBNet 55840. So that's bridge 6. And I can do a list port. And so basically what's happening here is these ports represent basically the endpoints, the containers. So here we have these in-filter and out-filter chains. And they are by default, we're throwing in anti-spoofing, and we're putting in the Neutron security groups by default. But the point is you can create and manipulate these chains with much more actions that than are available in just the default networking from Neutron. And then you can force them and put them on these port levels. You can put it on a bridge. You can put it on a router. And just depending on the direction of traffic, you can manipulate traffic. So you have a lot of choice there. So I'll just list rule. So it can be a series of jump chains, for example. And as you can see, here's an example of the anti-spoofing rule. So I know that this was the IP from the container that I retrieved through IPAM of Courier. And if it's not that, then drop it. So that's just an example. I think I ran out of time. I apologize. I did want to show you the manipulation of how you could change a chain and redirect things and drop things accordingly. But I just wanted to give you a little bit of a taste of that. And before I get kicked off, let's see. Just wanted to go back to the slides. And I'm way off here. So as you can see, there's still changes to be made with Courier. It continues to advance, at least as C&M advances, and as the container world continues to define the networking model. So the beauty is having a container and VM API that allows containers and VMs to talk to each other, which is actually capable of doing today through Kuryr and MidoNet. So having higher layer services from Neutron. Right now, at least this enables containers as first-class citizens. So the beauty of that is they can be treated with these security policies. The problem, which you may have observed, was I got a single IP for a single container, and that might not scale. So port forwarding, or port address translation would be a next step. And adding tags, as you saw, what I didn't like already. And then we continue to work towards mapping CNI. So it is challenging as a network vendor to move and shift with the changing world of these emerging and defined standards. So that's the next step too. So the two projects I did talk about today are both open source. So we would love for you to get involved, both on GitHub. Here are some details. We're on Slack as well. I'd love to chat more, but that, I think, is it for me. So thanks for your time today.
Thank you, Cynthia.